Okay, everything is a little bit on short notice, so excuse me when it's a little bit holprig, we would say in Switzerland, so it's not flowing perfectly. But yeah, so um, yeah, as the topic is 3D scanning, or at least the point with photogrammetry, which is the main topic of the tool Zephyr from 3D Flow, which will Federica talk about later. I will start a little bit of introduction, what I'm doing and where I use the whole technology from, or 3D scanning in total, next to other daily business in visual effects and other close areas, which is also always a part with cultural heritage, as well as business-wise, as well as private, because I travel a lot with my girlfriend, and the camera is always with me, and I shot a lot of pictures. Sometimes not really the fun of my girlfriend when she has to wait. I take a few thousand pictures of something to generate 3D models afterwards. So, yeah, my name is my name is Chris Blaser. I'm from Switzerland. I'm a visual effects producer, supervisor, visual effects data wrangler, and expert in 3D scanning. Um, so many things because of Switzerland is really small, so we don't have that big of an industry in visual effects, and it's also quite hard to get the hands on bigger jobs in Europe. But still, I did a few international productions. I'm also like Matthias VS member, Visual Effects Society member since last year after doing a few productions. And yeah, that's my main field. Visual Effects Data Wrangler, short for explanation, next to the Visual Effects Supervisor. The Visual Effects Supervisor is more the person. Sorry, I will have to close the window because the street is a little bit loud. So, um, Visual Effects Supervisor is the guy on set that is coordinating all the visual effects stuff happening on set with the camera department, with the director, with all other departments. So kind of the glue between the crew and the visual effects post-production at the end. The visual effects data wrangler is more into the visual effects and 3D model acquiring, meaning getting all the data what you need in visual effects and post-production at the end, also 3D scanning. And then 3D scanning expert, meaning that I'm going to scan for several companies. A lot of details is in different areas, from scanning houses to rebuild, scanning areas for planning, scanning for cultural heritage to preserve digital twins, virtual production stuff, also virtual, not virtual production, virtual reality stuff, of course, also, and yeah, industry, like having technical apparatus to make additional configurations or build additional parts, like for example the train company SBB in Switzerland, which I had the chance to scan stuff for them, to work with Siemens to add some scanning parts and engineering parts onto the trains. Um, the last few years, my main job, as I said, is more visual effects oriented. So this was the last productions, which in every case was 3D scanning or photogrammetry used during the production as well as after the production, especially Monte Verita because it plays 1906. So we had a lot of scans from ancient areas put together to recreate the style and the surroundings from 1906. Mad Heidi, of course, was a little bit different. Was more a lot of details what we used for pre-production. So we did on the reckoning from all the sets. We did complete 3D scans from the sets, so we could plan and do the post-production before. That we will show a little bit later. And TV show builder as well, we use there for getting through a window to show how we scan the window, open it, and then replace it digitally. So what I would shortly talk about, because photogrammetry often get referred for 3D scanning. Yes, that's true, but there are several technologies that being used. I actually use nearly all of them. It depends on the technology and on the time I have or on the range. But most of the time I combine photogrammetry with LiDAR, photogrammetry with other technologies. Here we have one of my LiDAR scanners, the big one that has a huge range, but it scans only black and white. We can then see that later. And when you combine this with photogrammetry, you get a precise representation of the 3D scan plus super high-res surfaces with textures, especially then for gaming, visual effects, really important. But since the LiDAR scanner is really fast, or at least this one is a little bit older, so it's not that fast as the newer ones, I can scan up to 700 meters with the precision of 3 millimeters within 360 degrees in a minute or less than a minute. So that's really accurate. And then afterwards, of course, I combine that with additional photogrammetry. Another technology I also use more than for small parts or for faces combined with photogrammetry is SLS scanning. That's structured light scanning. Probably getting more and more popular right now by getting cheap instruments like from what was it? I think Otter and a lot of other companies that start to build scanners on lower price segment. In this one I have, it's about 5,000 euros, and the newer ones you can get, it's about 500 to 1,000 euros. Of course, there is the price difference, but also the quality difference. On a cheap scanner, it will be not that accurate. And the last part that I use next to my photo apparatus, this is drones, of course, also with Zephyr, of course, because this is one major topic that Zephyr can handle and can handle very well against a lot of other companies' product. I have to say, Zephyr does a really great job and also a really accurate job in that regard. So, and yeah, I mean, drone scanning, I did scan from a few square meters up to, I think the biggest one was a mountain massive of 900-meter wide and 600 meters high in a precision of 10 centimeters. So this was like, I don't know, 8,000 or 9,000 photos flying a whole day with the drone non-stop to get the data sets handled at the end. My main part, what I use is my camera, photo camera. For this, I have worked with Sony. That's 7D EOS R7D, has 61 megapixels, and I shoot all raw, so I get really high quality images, but with most of the time, if possible, with ring flash, as you can see in the presentation, that is strong enough to gain the best quality out of the raw footage. Well, this is the point I will talk a little bit later on, why we need so much light for photogrammetry. This is another topic I can a little bit scratch on it. And then, yeah, as I can see as well in my background, these are prototypes I built with LED ring lights because especially on cultural heritage and artifacts, often it's not allowed to use flashlights because it can destroy the surfaces or the object itself. So we have to switch back to LED lights, standing lights, as well with infrared filters on top of it next to the polarization filter I use for getting rid of all the reflections. Yeah, so as I said in the beginning, and my presentation is a little bit short-term put together, but I have here one slide more before I go into other scans and into the software itself. That's a typical example which I work in the film industry, especially here for creating digital characters for virtual productions. As I said, I do a combination of SLS scanning and as well as photogrammetry. And here you can see several steps. I have to put on the laser pointer. So here you can see the different steps from the whole creation. The front one is actually the result from photogrammetry, the 3D model, the mesh. You can see it's not really clean. The second one is from an SLS scan that I did with the hand scanner. And then in the combination to create the full res textures as well as some details back from the photogrammetry, we combine the whole model and reproject in Zephyr both models to each other and then recreate the texture set to gain, for example, here an 8K version of the face from the person, which then we clean later at the final result to have a background character. Okay. Let's jump into Zephyr, the tool. I use always beta because I'm a beta tester, so that's why I'm working together with 3D Flow since I guess 6 years, 7 years, or even more. I don't know.
Yeah, I guess
But
so.
yeah,
Yeah, it's been
um,
quite a while.
yes, exactly. I started or get asked to work or to translate the software into German, and then I started to translate a lot of other things and get into the beta testing program. And now I'm working often together also to improve the software, get new ideas into it, and then yeah, create the best experience for the people who use the Zephyr as a tool. So to explain a little bit how Zephyr works, it's relatively simple to explain it at the start. Let me switch to SpongePoint Cloud. Actually, what photogrammetry is actually you take a bunch of pictures, as you can see here, in here. The pictures have to have an overlapping of around 70 to 80% from side to side, top down. So the software can calculate from at least 3 cameras or 3 position, 3 photos you take, the parallax of each pixel on the same spot. So what photogrammetry actually does in the processor called structure from motion is putting each pixel over several pictures into the 3D space and project that. The result will be at the first stage, like here, that's actually in Winterthur, close an old industry area. Putting in the sponge cloud state as the first state, an actual representation and alignment, each or a few pixels into 3D space. So you end up having here, maybe I should make the points a little bit bigger because I think this is too narrow. Yeah, here. So, um, appearance, no. Rendering. Point size. Like it. Oh, that was part 1, 2, and this one. Text size, point size. Yes. Okay. So the blue ones, that's the camera. What's special in here, especially in this one, is I tried to figure out if the software can handle a self-shooting 360 panorama head. Actually, it was a simple DJI RS2 Pro, so a gimbal actually, which has a 360 panorama shot function, and you can then data overlapping. And actually, I test a few photogrammetry tools, and Zephyr was the only one that realized from the beginning, without telling Zephyr something, that all the 48 pictures are actually an inside-out sphere of photos, and aligned them without saying, "Hey, listen, that's a group, that's a group, that's a group," which has to be done in a lot of others software. So that's one plus. Especially this whole thing was scanned with photogrammetry and as well with LiDAR scanning. So this is a LiDAR scan from my 3D scanner. Let me take out the cameras. That's one of first 3D scan position. As you can see, because of the long range of this scanner, I can scan nearly the whole alley down there. So what I did is all the scan positions here, as you can see, let's do another one, are scanned from each position, these circles. This one is another one. And then I also take this from the same spot, completely 360 volume with 48 pictures, which is a little bit too much, but it's okay for the first test. And then put together, I get at the end the whole 3D mesh. It takes a little bit to load because it's nearly 4,000 or 2,200 300 pictures. So get the camera. So this is the combination from the photogrammetry mesh and from the LiDAR scan. And as you can see, this is only a mesh, not the textured version, but still, when you look at this one, when you use the light, you can see better. It's very clean, and also you have a lot of details in it. So, and this can then, of course, remodeled or reused or structured down, that you can use that in virtual production. This was for a virtual production stage as well for a historic preservation. So yeah, that's the whole thing. Regarding some 3D scans, what I did, we have a little bit short time. I have to take care of the time, otherwise I will talk too long and take out time for Federica. In here, for example, this was done not professionally or semi-professionally. When you're doing, when you know what you're doing, you can do a lot of things. That was in my vacation in Egypt. I took along with me just a few LED lights. I built around my camera a ring system that I can mount these little LED lights. And since it's not anymore prohibited to do photos with professional equipment in Egypt, so I scanned a whole tomb in the Valley of the Builders, and that's the result of it. So, as you can see, when you have enough light to produce stuff, you can really get also first rough and fast, good quality. I mean, what you can see here, because this is a tool called Marmoset Toolpack. They have a web player where you can put on a HTML page 3D models. It's only limited to 4K, so it's several 4K layers, because the original is like X time 16K layers. That would be much sharper. Yeah, so then, of course, there's another one that's things as well from Egypt. But of course, when you know what you're doing, you can also do scans for games. That was from a computer game that I scanned this machine called Dumper, which then got remodeled as a low polygon model, for example. gasoline burner from a project we did from a museum in Switzerland from the World War II, which we scanned like 50 or 60 objects and artifacts to display them on holographic screens. For example, this was also in the bunker, scanned and then remodeled, because this is a cleaned up mesh, as you can see here, unlike 3D scan like this one. I think this is the original. Yeah, as you can see here, the mesh structure is really dense and not really useful for any other game or interaction versions. Good. I think I can cover a few more things, but the time is running out, and I have to hand it over to Federica to talk about Zephyr, and we can go to the Q&A later, and I can answer or show a little bit more maybe.
So yeah, as I was saying, I wanted to thank you for giving me this opportunity, and also wanted to thank Chris for asking me to join this presentation and this conference, and I mean, talk about the standard that is present nowadays in the vast 3D scanning world. Besides Chris and I, as Chris already said, we've been collaborating for quite some time now, so it's great to see how this kind of collaboration between companies and their communities. Now, this kind of collaboration leads to these opportunities, and also there's this mutual, understanding, and also mutual way of, I don't know, I need your feedback from your side, we can improve the software, and all this kind of connection that I'm really happy for. And also, Chris gave me some material during these years for social media posts and also articles. So it's so great to see how this collaboration goes, no? And yeah, in order to start with the real presentation, I wanted to spend just a few words on our company, in case some of you don't know our reality. So yeah, basically we are from Italy, and our company was born in 2011 within the computer vision research field. And we are about a dozen people right now in the team, which includes many computer vision researchers and software developers, and also collaborators from worldwide, and other people from the tech support and sales department like me. And yeah, basically what you're seeing now are the 3D Flow milestones. In the first years, we mostly did consultancy services, and then in 2014, we officially launched the 3D Zephyr onto the market. Since then, the software has become our core business, as we are constantly improving it in terms of accuracy, in terms of technology, on tools available, and we launched many releases. The last one, this is not updated actually, the version 8, not the 7.5, that includes also the AI powered tool for bot classification, and also the automatic masking. So yeah, don't mind this slide. Yeah, so I'm doing ahead. So what does Zephyr do in just a very few words? I mean, Chris already explained it to you, so I won't be long. Just to tell you that you can generate and extract 3D models out of pictures and video frame, but it's not just that. Actually, Zephyr is more than that, because as Chris already mentioned, you can use any kind of input data for your outputs. So not just the pictures and videos, but also 360 images and LiDAR data above all. Okay. So yeah, I'm going very quickly on this part here. The 3D reconstructions follows a workflow based on 4 different steps, and each step has its own algorithm that works behind the scenes. Besides, our technology is 100% proprietary and developed from scratch by our development team. And I wanted to tell you this because, I mean, it makes me proud. So, yeah, the last slide of this part refers to the target industries, which, as you can see, are kind of are several and very different from one another. But I mean, that's the point, because we purposely wanted to offer a versatile solution in which you can find specific tools that belongs to certain industries, but also you can perform many kind of action and all inside a single software. That's basically what Chris previously showed you, by showing different kind of scenarios from faces to whole cities surveyed with laser scan and photogrammetry. So yeah, basically now I'm at the core of this presentation, which I wanted to focus mainly on the role of photogrammetry for the cultural heritage and archaeology fields. Nowadays, the practice of accurately reconstructing finds, archaeological sites, works of art, and historical places and buildings in 3D for the purpose of documenting and preserving is increasingly felt and carried out using this method, which is defined as non-invasive. And these are the most common application in which you can leverage this approach, but the possibilities are actually way more. I already mentioned somehow the point one, which is the study and documentation at hand and the time of archaeological finds. Let's say that you have your 3D model and you can perform different kind of operation on your 3D model. You can zoom in to see and retrieve all the micro details on the mesh surface. You can take measurements, you can calculate volumes. You can also print it in order to have the, so to say, physical copy for further analysis. The point two refers to the restoration and constant monitoring of historical buildings in decay. And that's super useful because you can, for instance, do more surveys of a specific area in a specific period of time so that you can see the buildings or the areas changes over time. And having this kind of information is so important because it allows you to set up an exhaustive restoration procedure, because you know where to work on. The point three refers to the promotion and accessibility of cultural assets via museum and interactive installations. And I mean, some areas are difficult to reach physically. We'll see some examples in a few moments. These areas are difficult to reach mainly due to where they are located, I always bring the example of those castles that are so high and built on mountains. So, I mean, having the possibility to retrieve and to do the survey of those areas gives the possibility to people to visit them somehow, perhaps via a museum exhibition, or also with your computer by seeing the 3D model. So yeah, let's go ahead with the first data set that I want to show you. This slide is just to give you a very brief context. The first project is the so-called Verruca Fortress, an ancient bastion of the 12th century, located on the Mount Verruca in Tuscany. And it was once relevant due to its height and the strategic position, but then it was abandoned in the 15th century. And today is inevitably in an advanced state of decay. The survey was conducted by Professor Giovanni Pancani and some students of the architectural department of the University of Florence. And I mean, when planning the survey, and looking at the fortress location that we see that is, I mean, it's not easily accessible. It's on the top of this mountain, after all, as you can see from this picture here. The best choice was to choose photogrammetry and laser scanning, mainly aerial photogrammetry with a drone. And you can see here also the laser scan of these of the area that was later on added to the photogrammetry data in order, as Chris already mentioned, to have the best of both worlds. Now you have the metric accuracy given by the laser scans and the realistic color information given by the photogrammetry. I guess that we can see directly into Zephyr. Just let me go here. Okay. Please let me know if you see everything, but I guess so. So here we have the sparse point cloud, but let's go straight to the mesh. It will take a little while. Okay, let's now turn off the cameras. So you can see here in detail the geometry in this case. Then I'll show you the texture as well. So this is just photogrammetry, just to not avoid misunderstandings. But as you can see, the results is quite good on its own. Just let me go to the texture mesh. Okay, there you are. It's a bit heavy, and I am on a laptop, so have a little bit of patience. But you can see here the level of detail on the texture, which is really, really good. And you can see also the targets placed all around the area in order then to retrieve the correspondent GPS information and coordinates to have a scaled and georeferenced model. Okay, let's go back to this. Now it's to switch. Yeah. No, let me go back here. Okay. So yeah. Yes, this part already, you already seen it. So the final outputs, aside the photogrammetry 3D models, point cloud, mesh, and texture mesh, their final goal was to extract also plans, elevation profiles, sections, and orthophotos. And these were essential to perform instrumental analysis of the morphological profile of the rock and at the same time identify the degree of damage of this ancient building. Okay, now let's go to the dataset number 2, which refers to an international discovery made during the summer and autumn of 2019, so some years ago, where during an archaeological mission called KIFAP and conducted by Professor Daniele Bonacossi of the Udine University, this group of archaeologists found 10 Assyrian bas-reliefs located in Faida, in the northern Iraqi Kurdistan. As you read from the slide, they won the award for the most important archaeological discovery of that year, which is a worldwide recognition with a particular accent on cultural heritage located in areas at risk, and addressed to those archaeologists that not just discover, but also keep on documenting and protecting these areas every day. For this very reason, the team leveraged both the ground and aerial photogrammetry with drones, along with the differential GPS for the coordinates and to scale also and georeference the model, and also Zephyr coded targets to better drive the 3D reconstruction later in the software. So I'm sorry to do all these back and forth between the presentation and the software, but I wanted to show you the other 3D model in detail. So I'll go here. I will show you just one of the free 3D models of these free bas reliefs, 4 actually, which were the most well preserved, but it's just for the sake of time. So, but just to show you, because they are similar one to another. So I wanted to show you the geometry. Just let me zoom in a little bit here. So this is the bas relief number 4. And you can see also, let me turn on the RGB color and the texture mesh. Just a second. Oh, okay. Okay. This is where you see our coded targets, which are quite useful because the software will then automatically detect them, and it will use them to optimize the camera orientation. So in order to avoid artifacts on the mesh geometry and the texture as well. So yeah, this is the relief. So yeah, basically, this is one what I wanted to show you, because these two data sets were challenging in their own ways, but the results, in my opinion at least, are totally worth it, and show you what you can do with photogrammetry, and also with other kind of data mixed together, like, for example, LiDAR data and photogrammetry. Another thing that I wanted to add, which is not present in the slide, but is another information that I retrieved, is that in 2022, the Faida Archaeological Park was officially opened, and that it is the first of its kind in Iraq. So, I mean, for them, it's a very important accomplishment. And again, what you can do with photogrammetry and in general, the possibility of the 3D scanning for the cultural heritage. So I'll go back to the last slide, but I want to start with, yes, before going to the last slide, I wanted to show you the other reliefs, but they are pretty similar. So yeah, basically this is the moment of the video. So Matthias, if you want to start it, or I can start from here. I mean, it's the same.
I'll try to play it 1 second.
Okay. So I can switch off, stop the screen, the screen sharing. No. Let me. Okay, there you are. So first we'll see the video, then I'll give you some context in just 1 minute. So here we are. I wanted to show you this video in order to conclude the presentation. Just a second, that I will. Okay. Yeah. I will go I will stick to it. So just to give you a brief context, this church interior was, this video actually was sent to me by one of our longtime Zephyr users, which is the 3D artist Martin Zygmunt, that scanned the whole church. This is just a sneak peek, but if you go to our Instagram page, you'll see, if you scroll a little bit, the post, you can see the 3 minutes video long, which is a complete video. And I mean, I wanted to stress the fact that aside that this 3D model is just out of pure photogrammetry, I wanted to stress again and show you how far you can go in the 3D scanning world once you get familiar with the photogrammetry, because that specific interior, I mean, interior are challenging. Chris can agree with me. Because of the light conditions, because of the poor amount of light present, and also all the changes in lighting during the day. But once you, I mean, overcome these difficulties, so to say, with your expertise, the results are impressive. I was in awe when I saw it the first time, so I was like, okay, I have to show it in this particular occasion. So yeah, I guess I finished from my side. Here you can find our contact information in case you want to know more about our software or anything that I can help you with. And once again, I wanted to thank Matthew for these opportunities, and Chris for asking me to join. So thanks for your time, for your attention. I'll stop the screen sharing, so I guess that we can start with the Q&A session.
Yeah, that's perfect. Chris, is there something that you would like to add to that, or?
Yeah, just one little thing, especially what Federica told before about quality. I mean, as you can saw in the church, I mean, there is a few details missing behind the angels and everything because it's high on the ceiling, and probably was not prepared to scan it professionally or high
No, it was not
professionally, I would
professional.
say.
Mm-hmm.
But as a comparison, I mean, this, for example, this was scanned with a ring flash in super high-res details with 124 pictures only, and you can really see all the details within because of enough light and enough details in the photo. So when you, especially when you scan interiors, the light is always a problem because you need a lot of light. I mean, just to tell you about the whole thing, when you normally make a photo, then you have normal setups. But what we use to get the best quality out of it, we have like camera setups of 100 to 200 seconds. Then ISO at 100, really, or the lowest possible, ideally at 100 because it gains a lot of noise. And the lens closed with the iris to f9 or even higher to get the most range of depth of field that you don't have blurring elements in it. And so that's the point. And another thing is like this one, for 3D printing, I mean, I did that one as well then with 3D print out of this one. So that was also for a culture preserving from an artist. So from the little one here, the finger dog, as it called, out of plaster, then I did scan the whole thing and made then these little ones. So yeah.
Yeah, the possibilities are endless when it comes to photogrammetry. There are some, archenemies, so to say, like reflective surfaces, glass. I mean, everyone who does photogrammetry sooner or later just have to face these problems. But even if you don't reconstruct that tiny parts that you can, for example, then reconstruct manually into another 3D modeling software, but you have all the rest reconstructed with photogrammetry. I mean, it's you don't waste so much time modeling everything from scratch, and that's a great step forward. So it's a victory in a way, even if you have some issues. Okay. So yeah, I hope that people who is watching was happy with this presentation. For me, it's I was so happy to be here. So with Chris and and everyone.
Yeah, no, thank you so much for this presentation. Let's do a short Q&A. We did get two questions. I have many notes, but I would say for me the biggest question is now if with Zephyr you could scan the supposed underground city which they found with this, what was it, an SAR tomography technology under the pyramids of Giza that went through the media a couple of days ago.
I have to check. Okay.
No, jokes
Yeah, it
aside.
was a big topic.
So it was a huge topic, but jokes aside, no. Let's go to the to the official questions. So Srinivas asked. So the basic. I'm not sure. I'm just going to read it. Why Zephyr and not use other photogrammetry apps? So that was still during the presentation of Chris at the very beginning, right? So I guess this explained why Zephyr, because Zephyr or 3D Flow is part of this presentation with Federica. So, but let's continue. Is it dependent on the purpose, kind of which tool to use, let's say Zephyr or other solutions, or is it just a better software? So wink, wink. Or does it depend on the studio or the, let's say, independent purpose like visual effects or games or architectural visualizations that you would, is there a specialization of Zephyr, for example?
Well, I mean, from my experience, when it comes to the software itself, we're pretty agnostic, but I do see that over time we've been specializing, for example, more on the mapping and surveying field in terms of tools available. When it comes to the photogrammetry pipeline itself, I wouldn't say that we are addressed towards one field or another, but I do agree that, for example, we have the orthophoto generation, the DTM generation, the another thing, but well, control points. All the software we have the control point section. What I want to say is that I guess that every software has its own point of strength, and eventually the choice of one with respect to another depends on the user and what you find more comfortable with in terms of UI, in terms of workflow, in terms of what are your needs. There are many factors. When it comes to the photogrammetry pipeline, we are more or less, in terms of the workflow to follow, more or less equal. We are specialized in the tools and also in the laser scan integration, I would say, because we were the first one, if not one of the first ones. Okay, no, because I don't remember myself because I am not a developer, so I wouldn't, I don't want to give a false information, but I do remember that we were one of the first. And I mean, another thing which is perhaps not directly connected to the software, but related, is that we are a quite small company. And what does it mean? Is that if the user wants support and has questions on the software, they can reach out to us directly. and talk to us quite immediately. And it's not me that I say this, okay? It's from the feedback of our community that we have many channels, not just the most common ones, Facebook, Instagram, but we have also a Discord channel and forums, and also obviously emails, phone, and whatsoever. But the fact is, we want to offer a great support for our community, for our user base. Perhaps it's not directly connected to the software itself, but is a great plus, at least from my user point of view, final user point of view. I hope I answered.
I think that in general, support and community and feeling kind of welcome in general is something that I definitely users always appreciate, right? Yeah.
That's really the big plus to say, at least. I mean, the company 3D Flow, I mean, in each and every problem you have or need a solution or something, you get super fast response. They are
Yes.
always tend to help. Also, if you need, for example, you have a big contract and need to fulfill really fast scan reconstructions, so you can easily get 1 or 2 license just for a short time.
Yes.
As well, really helpful in a lot of things. And regarding software, I mean, from a user experience, of course, there is reality capture, for example, now from Epic, which is free up to 1 million revenue. But the problem is regarding LiDAR scanning, for example, I mean, sorry to say, but reality capture is far, far behind with the combination in photogrammetry. Super difficult. And I also use some other software sometimes, but if you know what you're doing, and you can really go really deep in Zephyr, and since they have a separate step, I mean, point between the most of the photogrammetry is that they go from sponge clouds directly to the 3D mesh. Zephyr goes between the dense point clouds, and you can clean up the point cloud or make a representation, remodeling, and then reproject the whole thing onto a direct 3D model and enhance it. That's an option that none of the other photogrammetry tools have. That's really a big plus. And yeah, even for that, that's not really would say professional, not really cheap software, but it's really great, and the support always nails it at the end. So
thank
you have to wait for 2 months at reality capture to get something back, but yeah, it's kind of an hour or 2, and then they get the response. So that's really great.
Respect. Yeah, I mean, some of the tools may be more known on the market, some of them may be less known, right? And but this is not everything fits every project, not everything fits every person. So I think this is why also kind of a part of the spirit of the 3D Environment Conference to also make people aware of other types of workflows or applications, right? Yeah, so there was also from Serini there was another question that was kind of slightly, it was mentioned how to deal with reflective surfaces and black surfaces which have less reflection. And that definitely is always a challenge, but I would assume that smart strategies with lighting may help. But
general,
Chris is the expert here. So.
Yeah. General, I mean, blacks and high reflecting surfaces are always a problem. Not only for photogrammetry, especially for photogrammetry, I would say, but not only for photogrammetry, even for LiDAR and S-less scanning. So there are only one scanner, nearly 2 scanner at hand I tried, which can scan high reflective surfaces, but we talk about 50 to 60,000 euros per scanner at that point, just a hand scanner. And the other thing, what you also do, it's this one. That's a scan spray.
Mm.
So actually, it coats the surface as a
Yes.
reflective shield, and then you scan that. You have to scan a second pass for the textures then to combine that. So means you have ideally when you have a turntable, when you can apply that one, then you can do that. Another way, what you can do, what I use is cross-polarization light with
Exactly.
the complete dark room. So the completely room
Mm.
has to be completely dark, and especially with special curtain that don't hit any light back. And then you have to scan the whole thing with this part, and then you can go. Okay. Another version is you have a turntable scanner or an automated turntable where you can time and have the same capturing grid from one to another scan, so you can spray the whole thing, scan it again with the only textures and with the polarization. So actually, what cross-polarization does, for just a short explanation, you have like on this one, you have pole filter
Mhm.
on the lights, and then you have in the center a pole filter on the lens that is 90 degrees shifted to get actually light, but you don't get the reflection. So you have actually albedo texture getting back. So it's easier for the software to reconstruct. And enough light from one direction, so you have a flat lit surface. That's the key. But yeah, reflective is always hard. I mean, just for an
Yes.
example, this one here, that's a measurement clock, was scanned in photogrammetry, and SLS, this one is only the photogrammetry reconstruction, but you can see it's okay with kind of cross-polarization, but it has a lot of holes and missing details because of the reflection light elements in the whole scene. So that's always hard. So, and you have to know a lot of things that you can do such things. Just to take out the camera and shoot this one, you can forget that one. You will not get any good results. So, yeah.
Would it be possible as an alternative to basically? I mean, I have no idea about these things, but technically, if you have something that kind of the reflectivity, if it's a static object and you take the picture, for example, from exactly the same location, if you kind of force the reflections to switch between two states. So let's say, I don't know, you have a like a panorama or whatever it is, or like a dome or a tent or something that you can slightly change,
Okay.
and then take basically two pictures from exactly the same location, and then basically say, based on the pixel switches, you know that this part is reflective, and then basically create some sort of delta to figure out which the reflective parts are. Like on a turntable, instead of the object rotating, it's like the environment rotating.
Well, the problem is, I mean, light reflection is also based on the same similar like incoming outcoming angle. So if you
Yes.
turn the environment, it's the same happening as you turn the object. So the problem is what you can do, but that's at the moment more in the area of machine learning. Actually, you could somehow train a system that can de-reflect the whole picture to gain
Mm.
elements that you can use. But I
Mhm.
think that's a crazy thing. I saw the opposite, creating, for example, HDR globe out of a single picture. That's easier to
Yeah.
be done because of the
Yeah.
surface reflection and everything. But for photogrammetry, and the other problem is if you use machine learning, so because machine learning is always
Mm.
only uh, a possible way of the reality or the truth, you get distortions. Even if you use machine learning denoise systems, you can get sometimes much worse results when you use denoise from machine learning than actual normal denoise without machine learning.
Yes.
because it's not the same proper pattern over all the pictures.
Yeah, I mean, there's this the problem also with the lens distortion, because I mean, I had some classes, some courses, training courses that we had in which the users asked us about this question. But actually, the distortion is an error, okay, but the software needs this error to orient the cameras into the 3D space. And somehow also the noise aspects works in a similar way. When it comes to photo editing for photogrammetry, the photo editing must be kept to a low level. Adjust just a bit the exposition, okay, the lights, the shadows, that's okay. But you cannot crop, you cannot rotate, you cannot do the lens distortion, and also the denoise, because in this case you'd have the pictures which are which don't have the original information that the software needs to place the pictures inside the 3D space and then go ahead with the reconstruction. So yeah, I mean these limitations are there. You need to accept it and somehow overcome it, even if partially. That's okay. I mean, Chris, as I said, is expert and already gave us many tips for me as well.
Yeah,
good.
no, I mean it's just capturing reality with physical devices. It's just something that is like you just have to accept that nature is not perfect, right?
Yeah.
So
But
let's
that's the beauty
do
in it.
yes. Let's do one more question because we could go forever just on this topic. So Simon Dixon asks, do the workflows allow for and or have you ever needed in projects to add or assign any context information to 3D scanned objects? So, for example, assigning part of a scan as a wall, building, etc. So it's like almost like classification or
Yes, we
tagging
implemented it.
parts.
We implemented it in the new version 8. It's on the filtering part, and you can, for now, we limited the classification to trees, buildings, and roads. But we are, in our roadmap, we are planning on adding some more classification items. So yeah.
Yeah. I mean, there are even some libraries out there which could be used, right? So, or image-based segmentation. There are, I think, Meta has some libraries which can be used. So that may also help, right? And I
Give some more.
assume. So I looked into this, or I was researching this field about a couple of months ago, and so if you would, it may be possible if you look at an object that was 3D scanned in the 3D viewer, then run on top the segmentation analysis, then you could pretty certainly map certain parts to certain semantics as a post-process, or different methods. Yeah. So let me see. There's another comment here. Wow. Thanks for the explanation. So Srinivas says, thanks for the explanation. Most of the photogrammetry I've seen are rough surface or single floor type of environment. Just curious, have you ever tried scanning a skyscraper or a city with lots of shiny buildings with a lot of windows? If you did, what difficulties did you face? So let's just give a very brief question and then go to the break.
So I didn't do any kind of survey like that, but I do have, I don't know if I have it here ready to see. Perhaps let me find the video very quickly, because when we launch the new version of Zephyr, we always do an highlights video with some of the more interesting data sets. So let me find the, not the version 8, but perhaps the version, the previous version. I don't know. Ah, there you are. Okay. So perhaps I
Can you
can.
place the link in the chat?
Yes. There you are.
If
Okay.
that works. Otherwise, I
Okay.
will.
Yes. And then it's the first data set actually, and it's they reconstructed the skyscraper, and but it's a more larger area. So the fact is that they did some close-ups on the skyscraper, but they also kept the drone quite distant, because in this way you won't have the reflection on the glasses. But I mean, this is you have to keep yourself distant. So you have what good and what pro and one cons, so to say. But yeah, we have this example for the people who want to see. And I don't have the data set with me right now, unfortunately. Let me check if I can find it.
I mean,
Guess that.
with especially in drone, I mean, with problem of glass structures. I mean, what's always best, you have an overcast day, so not really high
Yes,
bright sun. That's really
absolutely.
one must have day. So otherwise to say, when you
Mm-mm.
do like really cities and everything. Sadly, you cannot really deal with that all the time, because when you have a contract, you have to go scan in a certain days or range. But if you have a overcast day, the reflections are not that hard. As well as on drones, you can use polarized filters on the
Mm-mm.
cameras to avoid
Absolutely.
at least the really dense reflections, so you get down. And of course, the more, especially in Zephyr, the more overlapping you have, the more clear you get also a result with really difficult elements. And at the end, I mean, these days the glasses are not clean, since we have a lot of
Yeah,
dust and
you've
other
got a
things,
point.
so that helps as well. So if you want,
Yes,
for example, if you
yes,
like to scan a car surface, drive first through dirty roads and get it dusted in, and then you can
yeah,
scan it.
that will do. I didn't think of that. Yeah, you've got a
Yeah.
point.
Yeah, I would say if because Federica, you just mentioned you may have a few more links. So maybe it's best
Uh,
also, Chris, regarding these topics, send them to me via email. So I can in the YouTube link I can just add the links in the comments, or send them if there are more questions coming in. I'll forward the questions to you.
Hmm.
yeah,
But I would say let's wrap it up here. And yeah, I'm sure at the later conference we may want to hear more about the topic, more examples, and so on.
Absolutely. I
Yeah,
mean,
but
sorry. I mean,
all
yeah, I
good,
think
all good.
to go deeper or to show more details how the workflow is and everything, we need definitely more time. And then, I mean, I can talk about 2 or 3 hours just for a lot of details and stuff I used, like Mad Heidi, how much we used on set and visual effects. That could be one topic. Scanning for historical stuff for museum and
Mm-mm.
virtual reality stuff is another topic. And how to scan stuff and as well doing the workflow no matter which tools you use. Because actually, when you do it right, that's the best case. It's like shit in, shit out, of course. It means if you have a good data set, you get good results. If you have a bad data set, like you use
Yeah.
in a lot of the so-called scanning apps with the mobile phones with limited
No, don't do that,
possibilities,
please.
you don't get good results. Again, it
No.
doesn't matter how good you are, it's limited. That's
Yeah,
yes.
it's due to the sensor size of the camera. No, so you don't have enough space, physical space, to have all the good information for each pixel in the images. So yeah, basically it depends on your needs. If you want to approach photogrammetry, if you do it for fun, for to experiment, that's totally fine. That's totally okay. If you start doing some more professional projects, obviously the equipment has to change. So, but yeah, quite obvious, but not that much. Incredibly, we receive many questions or from users that keep on using mobile phone or also videos, and I am like, yes, you can extract 3D models from your input data from mobile or video, but if you want to, to hear a suggestion from my side, always still pictures instead of videos, and also at least a reflex camera, which is nowadays, it's pretty accessible in terms of costs, no? And you already have different kind of results, more accuracy, not just metric, but also when it comes to texture and so on. I mean, it's from my personal experience. Then obviously it's up to you.
Sweet. All right. Again, thanks a lot. So that's been quite a lot of very cool information. Thank you so much. Let's do a quick break, and then we'll be back with my presentation. All right. Quick
we are
break.
late. I'm sorry.
All good. Sweet. Let's do
Okay.
let me see, let's do a 5-minute break, everybody, and we'll be back very soon. Cheers.